Hello, friends. Uh, we have seen how to build a software product. We have seen the steps like the first step is you need to gather a requirement from the users so that we can build a software product. The next step is to think about the high level design, like what things should be there in the design, like if user interface is required and what kind of user interface it should be. Then the business logic, how you need to create the business logic, and if you have a database, and if what technology it will be used, like if it is a web-based product or it is a client-server product, and what layers should be there. So we have seen all these aspects for our two products, OBAS 1.1 and OBAS 1.2. So we have seen the high level design for this. Initially, we saw the requirement from the users, what requirements were there, and then we saw the high level design, and we also saw the user interface, how we will design the user interface. And in the middle level, in the high level, we saw the components, software components, and database data flow, how the data will flow in the system. So now we are coming to the crucial level of implementing the business logic. And since we decided that it should be a web-based product, and we also thought to build this product using object-oriented design. So now we have to build the classes, what classes should be there in the system and how they should be related, and then objects, thinking about the objects. And we will be seeing the object diagrams, sequence diagrams, state chart diagrams, etc. So first of all, let us see the classes. So in this application, essentially there is a user who has a bank account in the bank, and we have the functionality like bill payment, service request, etc. So from object-oriented design point of view, we should have classes like for user, because the user will be doing a lot of things, and we need to keep information about the user, like the user ID and the user password, username, the mobile number of the user, and address of the user. And we need to authenticate the user in the system when the user logins in the application. So we decided to build this class user, and it has user ID field, or you can say property, then username property, then password property, then mobile number property, and address of the user. And then we need to have the behavior of the authenticate for the user, so that the user will be able to log in the system. And we need to have account class, because we need to keep information about account ID, then account name, and then account number. And then we need to find the balance. So balance update should be a behavior, and then clothing balance of the user. Then this is also should be a behavior, and we need to create new accounts, so it should be a behavior. Then we need to close accounts, so it is also a behavior which is related to the account. So we need to have this class for accounts, and then we need to have a class for bill payments, because the user needs to pay bills. So what things we need to have about bill payments? So one is the biller ID of the biller. We need to keep in the system. Then the biller name. What is the name of the biller, which will be displayed in the user interfaces. and then what amount is paid for a bill. So that information we need to keep. Then date when the bill was paid, and the request for payment. This is a behavior, and it has to be invoked when somebody wants to pay a bill. And then response. So if the bill is payment successfully, then there should be a response for bill payment, like notifying the user that bill has been paid, etc. So we need to have this class for bill payment, and then we need to have a service request because the user wants to have request for due checkbook. So it is a service. So we need to create a class for this, and we need to keep information for request ID, and then request type. Currently, the request there is only one request type of new checkbook, but in future there could be other services. So we need to keep a request type, and then date of the request, and then user will be requesting for the service. So it should be a behavior. We should invoke the application to fulfill a service request, and then there should be a response for the service, like if the service was accepted or not. So this is all about the service request class. So we need to have these four classes for OBAS 1.1, and they are related as shown here. Like the user class is interacting with the account, and the account class will be interacting with bill payment and service request, because both bill payment and service request will be doing something with the account, like updating the account, etc. And there is other functionality for balance inquiry, so that will be taken care of by the account class, because it will not be interacting with bill payment or service request. So this much is enough for our use, and then closing the account, that is also functionality which also be taken care of by the account data account class. So for OWASP 1.1, this should be your information, seeing the user requirements, and from the design perspective, the components. So they will this diagram will fulfill the our requirements. And if you see the use cases and requirement specifications, you will find these information are needed from the requirement perspective. So our class diagram will fulfill all those requirements. Class diagram for OBAS 1.1 is shown. In the classes we have created, we can see that we have not included database connection management. So in these diagrams, we have not shown the database connection management. That is another perspective which we will learn later. We will discuss database connection management now, as all transactions in OBAS results in saved or modified records in the database system. From the component design, we can also see that database connection is required on each web page many times. Like in the component diagram in the high level design, we saw most of the pages uh, have some kind of database operation, and that is why database connection is required. So this means the connection with the database is an activity that is required to be performed many times. You can also realize that each class we have designed in OBAS will be connecting to the database many times. So these classes actually they also will be connecting with the database. Thus, it will be better to pool all the database connection related activities inside a pool of specialized classes, which will be dealing only with database connection management. So we will learn how we will be modifying our classes to take care of this aspect, the database connection aspect. Then from the requirement specifications or use cases, which we have described earlier, we can see that for each activity on the user interface, the user is required to provide the username, password, and account number for authentication. So from requirement management, we saw that for all functionalities like for bill payment or service request or balance, even balance inquiry, etc. Uh, on the user interface, the user is required to provide input for input boxes for username, password, and account number. This means that each of the activities of checking account balance, bill payment, service request, and account closure are independent of each other. So, uh, on all pages, we need this information. So, surely, like the information is not passing from one page to another page about these things like username, password, and account number. If there is only one response for each of these activities, then the system no longer keeps the information about a user after the completion of each of these activities. Thus, we do not need to keep the session variables to keep the information about a user after an activity gets completed. So, this means the session management is not required. Otherwise, we should have created session objects, and we need to manage some session variables to keep information about user and other information like account information and some transaction from one page to another page. As we can see that each activity involves the authentication of a user by checking the database entries for username, password, and account number. The authentication function is being used many times. So authentication function is used on all pages. Thus, we need to create a class for authentication function so that we do not need to write the source code for authentication function over and over. So authentication function, we should not be writing again and again for each page. It should be just one instance where we need to authenticate, and from there we can manage all authentication from each page. Like we can, for authentication, we can direct the code to one place where authentication will be done. Now let us come to object diagrams for OWASP 1.1. So the objects, like for example, which is provided here, there are two instances like of OBAS 1.1. That means two users are connected to OBAS 1.1 and they are doing some transaction. So the first instance, there is some user ID 1223, and this user has the account number 12, and this user is doing some bill payment, like he selected to pay a bill. So at that point of time, this object is depicting the operation which is done by this user, and there is one more object, one more instance of OWASP where user ID 4523 is doing some transaction, and this user has account number, and it is doing a service request. So at that point of time, there were two instances of OWASP. That means two objects were created at that time, two set of objects, sorry, because one set of objects has user, you can say user object, account object, bill payment object, and in the other set of objects, the user object, account object, and service request object. So this is how you create object diagrams. So this is one object diagram for OWASP 1.1. There could be many you can create to understand the design of the OWASP 1.1 better. The object diagram depicted in the above figure shows the state of the objects at a time when one object was processing bill payment and another one was processing a service request. Each of these objects is linked to the corresponding account and user objects. In this figure, you can see that user with a user ID 1223 is using Avast for a bill payment. At the same time, another user with the user ID 4523 is using Avast for a service request. You can create many object diagrams for Avast to fully understand its functionality and how to design the application. For example, you can create another object diagram where one user is creating a new account and at the same time two more users are doing some other transactions in Avast. So generally, object diagrams are a snapshot of objects at any given point of time. So there could be many object diagrams for a system. So we have shown one, and more can be created to understand the functionality of the system better. Then another kind of diagram which makes clear the design is sequence diagram. So here is the sequence diagram, one of the sequence diagrams for OBAS 1.1. So here we have the object user and the authenticate method of the user, which will be invoked when a user tries to log in the system. So this method will fire and a message will be passed to the account class or account object, and the account object then in response will fire. Say the user wants to make a bill payment, so payment request will be fired. So when the bill payment object is created, then there will be a response when the payment is made. When the user clicks the button to pay bill, so the response method will be fired, and then the this sequence of operations of method calls will complete after returning some values to different objects. And you can also see here object service request. This object may be there in the system at the time when this processing was going on, like when a user logged in and wanted to pay a bill. So these objects were created and they interacted through these method calls. But this service request object is not part of it because the business logic uh, written never wanted to make any call on this object. So you can see no calls are made up for this object, and this object is not part of this method calls. So this is one sequence diagram for OBAS 1.1. Sequence diagram for bill payment process for OBAS is shown in our figure. The user needs to provide the username, password, amount, and account number into the user interface of OBAS for bill payment. The user also needs to select the biller from the drop-down list. When the user clicks on submit button, then first the authentication method of the user object is invoked by the account object to verify the user. The payment request method is invoked later by the account object. After bill payment, the response method is self-called by the bill payment object. You can create similar sequence diagrams to fully design OBAS. So there could be many sequence diagrams, like in one diagram, there could be say service request operation or say uh, balance inquiry operation. So there will be many sequence diagrams like this. So to fully understand the design of a bus. And the next design diagram is the state chart diagram. So state chart diagrams, what they do is they show the entire life cycle of an object. So here we are showing the bill payment object and its entire life cycle, like from when it get initialized, and then it goes through some state changes, and finally this object is destroyed and after the completion of the transaction. So let us see here They suppose a user wants to pay a bill, so the user invokes this bill payment, and this bill payment object is created. So it will be in the initial state, it will be idle, and when the user says selects a bill, then the user the user will be doing actually the billing, selecting a biller and the amount. So next one is he will input the amount, how much amount the user wants to pay, and the user will pay the bill, like submitting, like clicking the submit button. And so this will be again a change of state for this object. And finally, uh, the user will be shown a receipt of bill payment. So again, there is a change in the state of this object. And finally, when the transaction is complete, so this object will be destroyed. So that is the final state. And there is one alternative life cycle for this object, like when the user selected bill payment and then for some reason decided not to pay the bill, he will cancel the bill, like like clicking the cancel button or something. So in that case, the object will not go through this all cycle, intermediate states like select bill, input amount, pay bill, etc. In fact, there the object will be destroyed just after clicking the cancel button or clear button. So the other alternative live for this object bill payment. So you can create state chart diagrams for other objects also, like for service request or for balance inquiry, etc. The state chart diagram for OBAS 1.1 is given in the figure. Please note that we have used commonly understandable English words in place of actual method names to understand this diagram better. This state chart diagram describes the states through which an object of bill pay type goes through from its initialization to finish. First, this object is created by a call in the software application. At the initial state, the bill pay object is idle. When this object is initialized to perform a bill payment transaction, the first state it goes through is when the bill payment object becomes active and is loaded onto the web page. In this state, the list of billers is also loaded in the object. When a bill type, that is a biller, is selected by the user, then this object moves in the next state, select bill. Naturally, this state is invoked by a user. Then the user enters the amount to be paid against the bill. The user then pays the bill by clicking the submit button on the user screen. So again, we see two more changes in the state of the object, like inputting the amount to be paid first, and then clicking the submit button. So two more states, and then uh, when the next state of the object will be the show receipt stage. This stage in the life of the bill pay object is in the form of a response page where the bill payment statement is shown. After the response page is displayed, the bill payment object is destroyed. This is the complete life cycle of the bill payment object. The other one I had shown, like when the user cancels this transaction. So that is alternative life cycle of this object. And in the figure above, the mapping of words used with the states of the object with the actual methods and properties is given. So here is the mapping, like the words we use there, and what actually function or property is getting changed. So when in the diagram we show bill payment, Actually, we will be populating bealer list in the drop down list. And when we do select bill, then the biller will be selected from the drop down list. And then input amount is like when we have this method, paid amount will be fired. And then pay bill when the payment request is made, like when the user clicks the submit button. And the show receipt state is when the response page is displayed to the user. And then cancel bill is when the cancel button or clear button is pressed. You can draw similar state chart diagrams for other objects such as service request, account balance inquiry, etc. And now let us see the class diagram for OBAS 1.2. So other things are same, and some changes like addition of transfer money. So this is a new functionality, and a new class has been created for transfer money. And this should have properties like transaction ID for money transfer, then amount, what amount to be transferred, and then date of the transfer, and the account number where the transfer money has to be sent, and then transfer request. When the user wants to make a transfer, then some method is to be invoked which will process that request, and there should be a response method which will show to the user if the transaction was successful. So this was for class diagram for OWASP 1.2. So the class diagram for OWASP 1.2 includes the money transfer class. All other classes remain the same as in OWASP 1.1. This new class money transfer money is used to take care of the methods and properties that will be needed for money transfer from one bank account to another bank account. Currently, OBAS only supports money transfer between bank accounts which are kept in the same bank. So currently we are not taking care of other things like transfer from some other bank, or transfer from some any other kind of agents like Western Money, uh, Western Union Money Transfer, etc. And here is the object diagram for OBAS 1.2, which is very similar to the object diagram for OBAS 1.1. So we, for demonstration purpose, again we this is a snapshot of the OBAS system when some transactions were going on, some users were doing some transaction. So here we are showing three transactions. So there were three users at that point of time. One user was doing bill payment, the other user was doing service request, and third user was doing money transfer. So three, that means three users doing three transactions in the OBAS system at that point of time. The object diagram depicted in the above figure shows the state of the objects at a time when one object was processing bill payment, and another one was processing a service request, and the third object was processing money transfer. Each of these objects is linked to the corresponding account and user objects. While discussing the class diagram, we mentioned about refactoring the classes to make it possible to reuse the source code. This is possible because we can create classes for the database connection and user verification. The method from these classes will be used frequently by other classes. The main task associated with account balance inquiry, new account creation, bill payment, service request, and account closure can be implemented by using classes. These classes can be compiled and stored at the application server. This alternative is good when a large number of web pages will be using these classes. Another alternative is to write the source code for these classes directly on the web page in the form of client side or server side scripts. This approach is fine when each class is used only on a few pages. Thus, there is not much repetition of source code. We have used this approach to build OBAS. While classes have been built for reusing the source code for database connections and user verification, the classes that implement all the required functionality for accomplishing the task related to account balance inquiry, bill payment, and account closure can be put inside the server side scripts. There is another aspect that we have considered. If you look closely at the requirement specifications, you will find that out of all the functionality in OBAS, there are only two current components that deal with the creation of new records in the database. The first one is the creation of a new bank account, and the other is the checkbook request. We decided to create compiled classes to achieve these functionalities. All other functionalities have been implemented using server-side scripts. The final solution that we have implemented includes a controller as well. This controller has been implemented to identify the user interface from which a request is coming. Based on the user interface from which a request comes, further processing is redirected to the appropriate piece of source code. For example, if the user request came from the user interface for creating a new account, then this error request will be redirected to the source code that implements the functionality to create a new account. The final solution consists of following classes. So the final classes I am showing now based on the refactoring and then database management, etc. So we have a create servlet class. This class is the controller that redirects the user request to various pieces of source code. So in the create servlet class, we have uh, methods which will redirect the user request to the appropriate code, which will be there in another other classes or server-side scripts. Then we have a DB initializer class. This class contains information about the database connection string and database management. And then we have a getCon class. This class tests the connection to the database. So this is also important because we will be opening database connection, then closing database connection. So that also can be put inside the class, and this can be reused whenever required. Then register user. This class implements the creation of a new account as well as the creation of a new checkbook. So this class is used to create a user account and to create a new checkbook request. Then verify user. Verify user. This class verifies the user by comparing the input values entered by the user for username, password, and account number with the values existing in the database. So this class is also reused many times because every time the user is doing some transaction like bill payment or balance inquiry, etc. Uh, the user needs to be validated to find out if the user has account to access the bank account system or VAS system. So whenever user is doing some transaction, so verify user will be the code will run in the verify user and it will be reused. So these classes have been created as compiled classes, and the rest will be implemented on the server side scripts. And actually, we implemented this application in Java. So we have wrote Java server pages where the other code so will be written directly. They will not be compiled code. One more information at this point. is that the database string, like the username, password, and database name, etc., they are sensitive. Like if they are, if you provide them on a server-side script, that means somebody can read those information and can misuse. It is possible to hack scripts, server-side scripts. You cannot hide them. But if you provide this information, connection is information with the database, in compiled code, that code is in binary machine code. So even if somebody hacks that information, then it is reading that piece of code will be difficult. It will be a binary code. So finding out the database name or username or password will be difficult for a hacker. So that is why we have put them in compiled classes. And then let us talk about user validations. So the use cases mentioned about user validation for the inputs provided by the user. All user validations have been implemented in the client-side scripts. These validations include password length check, like the length of the password, and field left blank. If the user has left any field blank, so again we validate that, and we will provide a message box to the user that some information was not put in a input box. So user will go back and provide that information, and then we also validated for string input in a numeric field. Like there is a numeric field for phone number. So phone number, if somebody puts some character or string in that field and clicks the submit button, the system will check that it is a string, and it will provide a message box to the user that it is a numeric field, and the user needs to provide numeric value. Then numeric input in a field which should accept only string values. So we also are checking if strings are required but numeric input has been provided. So we will inform the user to provide the string values. Then there are also validations to check the amount in a bank account should be sufficient to cover the transfer of money into another bank account. So when there is a transfer of money, like in OBAS 1.2, there is a facility to transfer money from one account to another account. Then uh, there should be sufficient funds in one account so that the person can transfer some money. So, for example, if an account has an opening balance of US $300, and the user who owns this account wants to transfer US $400 into another account, then the validation is there to stop such transaction. The user is provided with a message stating that there is not sufficient amount in the bank account, and so this transaction cannot be completed. Then for AWAS 1.2, there is a fee of US $5 for issue of new checkbook. This fee is deducted from the bank account of the user. The amount in the bank account of the user should be equal to or more than US dollars 5 to cover the charge for the issue of the checkbook. If the user is provided with a message stating that the amount is not sufficient in the bank account, and so this transaction cannot be completed. Uh, all the above mentioned validations cannot be implemented through client-side scripts. So these, like initially we saw the client-side validations for say field left blank or a string value in a numeric field or password check. But when we need to find out the balance in a bank account, so that cannot be done from client side scripts. So you need to connect to the database and find out the balance in an account, and only then you will be able to do validation. So these can be done only using server-side scripts. So these validations for fund availability in an account is done. We have done through server-side scripts. So this was all about the design aspect for the middle layer of the bus, both 1.1 and 1.2. Next, we will see the database design and find out how the database should be designed. And after that, we will be actually implementing all the design we have done, and we will write pieces of code to build the software product. So thanks for your time and bye for now.